Hello, thank you for checking out Mr. Ware's videos, and today we're looking at some symmetry. We're talking about three different types of symmetry: line symmetry, point symmetry, and rotational symmetry. Alright, so let's begin. So line symmetry is a figure that folds into itself. It can be mapped onto itself if you draw a line of symmetry. So if you can find a place in your figure and draw a line, it's going to have a mirror image across that line. Thus the little mirror over here. Excuse me. All right. Next up is point symmetry. Okay. Point symmetry is a figure that if you turn it upside down, it looks exactly the same. It means it looks the same upside down. So if I took this in and turn it upside down, it will look just like an N. Look like the original shape. And then finally, we got rotational symmetry. Okay. Anything that can be turned less than 360 degrees, I put a 360 donker here, less than 360 degrees, then and looks the same, then it has rotational symmetry. So those are the three: line symmetry, point symmetry, and rotational symmetry. So what we're going to do is take a look at some figures and see if they have 1, 2, 3, or none. Alright, so here are the four figures we're going to look at. And it says determine if the figure have line, point, and or rotational symmetry, and check all the ones that apply. So we're going to do each one of these shapes one at a time. Let's start with this first polygon. Okay, so the first thing I want to do is look to see if it has line symmetry. So I could draw a line straight through here and fold this up like a sheet. And it'll fold right onto itself. It's a mirror image if I fold it across that line. You can also have a mirror image if you fold it across this line. So that's a check for line symmetry. Alright, next we're going to check point symmetry. Okay, so point symmetry works as if you could turn it upside down and it looks exactly the same. So I'm going to turn it all the way upside down like so, and it still looks like the same shape. So it does have point symmetry. Now, keep in mind this: if your figure has point symmetry, which is if you turn it upside down, that's 180 degrees. So everything that has point symmetry has rotational symmetry as well. Okay? So everything that has point symmetry has rotational symmetry because that's less than 360 degrees. Now, everything that does not have point symmetry, or everything that does have rotational symmetry, may not have point symmetry. Okay, but anytime you're checking yes for point, you can also check yes for rotational. All right, so that takes care of number one. Let's look at another shape. All right, so here, first I'm gonna try to draw a line, and I could draw a line right down through here, and it'll split it in half and map itself. Okay, I could also draw a line that's diagonal, or this way, and it will map onto itself, so it has that reflection, that mirror image if you draw a line of symmetry. Okay, so it has line symmetry. It does not have point symmetry because if I turn it upside down like so, it doesn't look the same. So it does not have point symmetry. All right, now we're going to check rotational symmetry. So if I turn it less than 360 degrees and it still looks like the original shape, like so, all right, then it has rotational symmetry. All right, so this is an example of it not having point but does have rotational symmetry. Okay, so that's number two. All right, now we're going to take a look at this shape. Okay, we're going to draw a line. And I can't draw a line so that it maps onto itself. So here I drew a line. And if I fold this over, it wouldn't map onto itself. It's not a mirror image or reflection. Okay, so it does not have line symmetry. Okay, doesn't work this way either. All right, point symmetry. So we can turn it upside down, 180 degrees, and it still looks like the original shape. So it has point symmetry. Okay, and remember, if it has point symmetry, then it also has rotational symmetry as well. All right, let's check this last one. Okay, here we're going to try to draw a line. Draw a line through here and see if it can map, and it does not. It's not a perfect, it's not a reflection. It doesn't look exactly the same on or opposite from each other on both sides of the line. So it does not have line symmetry. Doesn't have point symmetry either. So if I turn it upside down, like so, it's a completely different shape. So it does not have point symmetry. And rotational symmetry. There's not a spot where I could turn it and it looks exactly the same. It doesn't look exactly the same until it comes all the way back around to 360 degrees. So it does not have rotational symmetry. So this one's one that's none. All right, so take a look at these answers or these questions and see if you can figure out if they have line, point, or rotational symmetry or none. All right, let's take a look at the answers. Okay, and that's it. That is a lesson on line, point, and rotational symmetry. I want to thank you for checking out Mr. Ware's videos. Have a nice day.